Okay, so this video is going to focus on two things, efficiency first and then power. Okay, so when we talk about the efficiency of a system, what we're looking at is just a comparison of the energy that's put into it and the energy that comes out. And so if you take the energy that is put in, or the energy at the start, or the initial energy that something has, and the energy out, then and divide those, you can turn into a percent, and then you get efficiency. So for example, let's say that you have a ball. Oh, let's do this. Let's do a little energy question. So let's say we have a cart on a ramp. Okay. And let's say the ramp is 2 meters tall. Okay, and it's going to go down this ramp. Say it has a mass of 1 kilogram. And so if it rolls down this track, it's going to gain velocity, and it's going to convert, or transform rather, gravitational potential energy into kinetic energy. And so we're going to say that we're starting with gravitational potential energy, and then over time it's going to transform into kinetic energy. Okay, and so we could say mgh equals 1/2 mv squared, and we can make a prediction here that it should be going, let's see, so 1 kilogram times 9.8 meters per second squared times our height of 2 meters equal to 1/2 times 1 kilogram times v squared. We could solve for v here. So we have 19.6 joules of energy. We solve, we get a v of 6.26 meters per second. So if this was the case, this would be a 100% efficient system, because all of our 19.6 joules of energy that we started with is what we ended up with. Okay, because what we just calculated basically was how much energy 19.6 would be, or how fast something would be going if it had 19.6 joules of kinetic energy. So 19.6 over 19.6 is 1, and as a percent, that's 100% efficiency. Okay, but let's say that instead we, instead of going 6.26, let's say a bunch of that energy was lost to thermal energy, and it was only going 4 meters per second. Okay, and so now we want the efficiency of this system. Well, we'll do the same thing. The energy out divided by the energy in. So in this case, energy out would be 1/2 times 1 kilogram times 4 meters per second squared, okay, which is going to be 8 joules of energy. 16 divided by 2 is 8, so 8 joules of energy. So if we say 8 joules over 19.6 joules, we're going to get an efficiency of about 40.8%. Okay, that means that in this system, 40.8% of the energy was conserved, and then the other 59.2% would have been lost to thermal energy. And we could even multiply the 19.6 by, or we could subtract them even to find out how much thermal energy was actually created. So this is efficiency, and so efficiency, just energy at the end divided by the energy at the beginning. And we'll do some labs where we actually take measurements and compare those things and get the efficiency of something. Okay, and this next piece we're going to look at will be pretty quick too, and this is that we're going to focus on is power. So power is equal to the change in energy or work, depending on the context, divided by the time. And this is actually technically average power, but we're not going to learn about instantaneous power. So, and that's basically what it is. So if you think about anytime you change the energy of something, if you can figure out how fast that energy changed, then you can get the power. the units for power are watts or joules per second. We're already familiar with it a little bit from the circuits. And then you can also measure it in horsepower. Okay, so anyway, so let's get a quick example. So let's say that you lifted something up. Let's say you raise it up 5 meters in the air. Okay, let's say it took maybe like 20 seconds to do so. Okay, and so if we wanted to find the power, what we'd do is we would divide the change in energy by the amount of time it took. Well, when you lifted this thing up, you gave it potential energy. So you kind of did work on it and transferred potential energy into it. So remember that potential energy is mgh. Okay, so we gained, let's say we have to give it a mass too. Let's say this object had a mass of 2 kilograms. So we gained 2 kilograms times 9.8 meters per second squared times 5 meters, and that's going to give us 98 newtons of energy. Okay, so if we, sorry, not newtons, apologies, 98 joules of energy. And so if this object gained 98 joules of energy in 20 seconds, then the amount of power that, or rate that energy was being transferred into it would be 98 divided by 20, which would be about just under 5 watts. Okay, so that would be 5 watts of power. Okay, and you can do a comparison. So when we talk about energy and power and stuff, maybe you've seen like the ratings on light bulbs. So if you have a light bulb that is rated for, let's say, 30 watts, that means that it consumes 30 joules per second. Okay, well the amount of energy transferred into this bulb in 20 seconds, well, that's couldn't even power a 30 watt bulb for a second. So, or it's not even enough to power a 30 watt bulb. Okay, because it's going too slow. But these are the basics of power. We'll do some calculations with power too. Okay, please let me know if you have any questions.